Okay, part two. So as I stated, we've already filled up most of a page. So I am going to go ahead and start a new page just to keep things a little clearer. Bring back my original notes. So we had just finished finding we had found both the velocity vector and the angular velocity vector of this object. And just to sort of drive home a point, even though we had this rotation about the z-axis, and even though we can think about the object rotating about this axis OC, in fact, because it's rolling without slipping, instantaneously our angular velocity vector has to be pointing along the y-axis. And in fact, since it's rotating instantaneously in this direction at this moment, our value of omega is going to point there. And because this object is spinning around, it's always going to point along this axis from the point where it's rolling without slipping and the center. So the fact that this is undergoing an angular acceleration is happening because this vector, this omega vector, is rotating along in this direction. So from the previous paper, we had determined that our value of omega at this instant is negative 0.866 radians per second, negative, and that's in the j hat direction. Now, as I said, this rotates around the z-axis, and it's going to rotate with this frequency. And so if we think back to section 16.8, the bug on a frisbee type problems, where we in essence are looking at something in a rotating coordinate system, if we were to rotate along, this value omega would be fixed. So we can think about the omega of the frisbee as being this omega z, or 0.5 radians per second in the k hat direction, in which case our angular acceleration alpha would just be equal to this value of capital omega, which is how our coordinate system is rotating, crossed with our actual value of omega, and that's this vector pointing here. So if we then plug in those values, we have 0.5 k hat crossed with negative 0.866 j hat, and work that out, and that's going to give us an angular acceleration vector that's equal to positive 0.433 I hat, and that's measured in radians per second squared. Again, takes a little bit to get used to thinking about these vectors. Our omega vector is pointing in this direction. Our alpha vector is pointing in the positive I direction. Notice that it is perpendicular to this angular velocity vector omega. So we've already found our velocity vector. Again, repeating from what we had before, our velocity vector is equal to negative 0.225 meters per second I hat. Then if we want to write down our acceleration, a sub a is equal to alpha cross r sub a plus omega cross r, r sub a. And remember, this omega cross r sub a was in fact equal to v sub a. So we could just directly plug in that expression since we've already found that before. Again, from before, we can pull the value of our r vector. R is going to be equal to 0.150 j hat plus 0.260 k hat, and that's converting both of those measurements to meters. So let's move way over to the side here because we're going to have a bunch of terms to plug in. We have alpha, which is 0.433 I hat, crossed with r, which is 0.150 j hat plus 0.260 k hat. Going to hold off on units for a while, plus our value of omega, which was negative 0.866 j hat, crossed with omega cross r, which is equal to v sub a, so that would be negative 0.225 I hat. So we have an I cross j, and that's going to give us a k. We have a j cross I, that's going to give us a negative k, and then we have an I cross k, that's going to give us a negative j. So we're going to have three terms total that we're going to end up adding all together. So then this is going to end up giving us negative 0.150 1125j hat. That's just our I cross k, giving us negative j, and then multiplying those two numbers. Then I'm going to have the terms over here. I have plus 0.0650 k hat minus 0.1949 k hat, bringing all those terms together, negative 0.1125 j hat minus 0.130 k hat, which thankfully is the answer in the back of the book. So definitely read through the examples given in the book. Definitely go back to the beginning and work through this again. And just to show off some of my art skills, this is me working through it. I've gotten pretty good at drawing Pokemon. This is actually one of my earlier attempts with Pikachu. You can notice I haven't fully finished shading his body, but overall not bad. All right, that's it for part 2. Later.